More than 95% of production has collapsed, and tens of thousands of hectares of orange groves have been abandoned. Florida, once known as the orange capital of the United States, has suffered unprecedented losses for more than 2 decades since the arrival of the Asian citrus psyllid. From being Brazil's biggest rival on the global market, Florida's orange industry has now even been overtaken by California on its own home turf. Yet every year, more than 10 million boxes of oranges are still harvested to sustain the state's iconic orange juice industry. So what is helping Florida farmers continue to hold on despite disease outbreaks, hurricanes, and rapidly rising production costs? Today, join Agriculture Insight as we head to Florida to explore how people and agricultural technology are fighting every day to save the orange industry that once became a symbol of this land. Everything will be revealed right now. Florida, one of America's wealthiest, fastest-growing, and third most populous states, holds countless advantages for tourism. Yet it also carries major weaknesses when it comes to agriculture. This peninsula faces a long list of natural disadvantages: sandy, nutrient-poor soil, hot and humid conditions that easily encourage fungal diseases, and a location directly in the path of many Atlantic hurricanes. So why was it this seemingly unlikely place, filled with every reason to fail, that created a miracle with oranges? The answer lies in the very thing Florida has the most of: sunshine. Orange trees need sunlight to build sugar, warm weather to grow, and winters free from hard freezes. Conditions that Florida provides almost perfectly, with more than 230 sunny days each year. With more than 800,000 acres of groves, nearly 90% of Florida's oranges are used for orange juice production. Unlike California, which is better known for fresh-eating oranges sold to supermarkets and export markets. However, Florida's massive citrus boom began to show its first cracks in the late 1990s because of a creature only a few millimeters long, the Asian citrus psyllid. Few could have imagined that this tiny insect, likely carried into Florida with imported nursery plants used to expand the citrus industry, would become the force pushing a hundreds of millions of boxes orange empire toward collapse. When it feeds on tree sap, the psyllid injects bacteria into the phloem, the system that carries sugar and nutrients through the orange tree. From there, the tree begins to decline. Large numbers of fruit drop early, while the remaining fruit becomes smaller, darker, and produce juice that is weaker, more bitter, or harsher than normal. For Florida, this was a direct strike at the two foundations of its orange industry: yield and juice quality, as even groves that still bear fruit become increasingly unable to meet commercial standards. More seriously, citrus greening remains one of the most dangerous diseases affecting citrus trees, and still has no definitive cure. In Florida, the spread has become so severe that on average, more than 90% of the area within an orange grove is affected, with more than 80% of the trees showing signs of infection. In just 3 decades since the Asian citrus psyllid first appeared, Florida's total orange production has fallen by more than 20 times. Industry-wide losses are estimated in the tens of billions of dollars, forcing many farmers to leave the business, leaving orange groves abandoned, and pushing many farms to sell their land for housing projects and urban development. In other words, Florida's orange industry was not brought down by a single event, but by a tiny, silent biological invasion that has dragged on for decades. But disease was not the only challenge. Sitting directly in the path of storms from the Atlantic, Florida is like a target in front of hurricanes, with winds that can exceed 200 kilometers per hour. Hurricanes did not bring HLB into Florida, but they made the situation worse. Powerful winds caused massive fruit drop, while orange groves already weakened by citrus greening became even harder to recover after each storm season. As an inevitable result, the impact of Florida's orange industry crisis quickly bounced back toward American consumers. On supermarket shelves, orange juice prices have jumped nearly 14% compared with last year, forcing shoppers to either accept higher prices or switch to alternatives like apple juice or cranberry juice, more stable options for saving money. So is there any way for Florida's orange industry to return to its golden age? Yes, but the path is far from simple. Because HLB has spread so widely, Florida growers can no longer realistically remove every infected tree. Instead, they have shifted toward a more practical strategy, living with the disease and keeping trees healthy enough to continue producing fruit for as long as possible. Across orange groves, insecticides are still sprayed multiple times a year to reduce Asian citrus psyllid populations. Drip irrigation systems have also been strengthened, since trees infected with HLB often suffer root decline and absorb water less efficiently. At the same time, yellow sticky traps are placed throughout the groves to attract and monitor Asian citrus psyllid populations, helping farmers detect potential disease outbreaks at an early stage. Young leaves are also inspected regularly, while crop protection products and micronutrients are applied to keep infected trees from declining too quickly. For new plantings, the battle begins right at the nursery stage. Research institutes and companies are continuously developing disease-free, stronger orange varieties with better tolerance to HLB, raised inside insect-proof screenhouses. Out in the grove, young trees can also be covered with protective mesh to prevent Asian citrus psyllids from reaching them during their most vulnerable stage. Some newer studies also use kaolin mineral coatings mixed with red iron oxide sprayed over tree canopies, making it harder for psyllids to recognize citrus leaves and reducing their feeding activity. In other words, Florida is no longer fighting one decisive battle against HLB. Instead, it is fighting through layer after layer of smaller defenses, reducing psyllid populations, keeping trees healthy, protecting young trees, and extending the commercial life of the orange groves that still remain. Although orange prices continue to rise sharply and supply is becoming increasingly scarce, demand for vitamin C in the United States has barely declined, especially among industrial orange juice plants that depend on huge volumes of raw fruit each season. From around October to early the following year, Florida's orange growing regions enter their main harvest season, even though today's output is far lower than during the industry's peak before citrus greening broke out. Although mechanical trunk shakers can knock down thousands of oranges in just a few seconds, many growers are still forced to rely on manual harvesting because trees infected with greening often have weakened root systems, more brittle branches, and unevenly ripened fruit. Thousands of seasonal workers still have to wear picking bags across their chests and climb ladders in Florida's hot, humid weather, hand-picking oranges one by one for hours at a time. Most workers are paid by output rather than by the hour, often earning around $80 to $150 per day, depending on their picking speed. An experienced worker can harvest thousands of pounds of oranges in a single shift, but this comes with intense physical strain on the shoulders, back, and knees. To keep the fruit from bruising and avoid breaking fruit-bearing branches already weakened by disease, workers must gently twist each orange from the stem by hand, then drop it directly into the picking bag before emptying it into large collection bins placed throughout the grove. This dependence on costly manual labor amid a prolonged disease crisis has turned the effort to save America's orange industry into a race against time, one in which science and technology are now seen as the final shield protecting groves that are slowly losing strength. Meanwhile, in California, which has now become America's orange capital, this season is also entering the peak of harvest. But compared with Florida, its current output can be nearly 4 times higher. The reason is simple. California has not been devastated by the Asian citrus psyllid and citrus greening disease as severely as Florida. Although orange acreage in the state now reaches hundreds of thousands of acres and serves as the backbone of America's fresh orange industry, orange harvesting in California is still mostly done by hand. That is because most California oranges, especially Navel and Valencia, are sold directly on supermarket shelves, so their peel must remain almost perfect, with scratches and bruising kept to an absolute minimum. Both states are deeply tied to oranges, but if Florida is fighting to keep its trees alive, California is fighting to keep every orange beautiful enough for the supermarket shelf. Back in Florida's orange groves, once the harvest is finished, all the oranges are loaded into large truck bins and quickly transported to juice processing plants, usually within 24 hours, to preserve as much freshness, juice content, and natural flavor as possible. At the factory, only oranges with the right Brix and acid ratio are sent into the extraction line, because this index determines the familiar balance between sweetness and acidity in American orange juice. First, the oranges are sent through recirculating wash tanks, where high-pressure water continuously removes soil, leaves, and residues still clinging to the peel surface. Immediately afterward, the oranges pass through a series of soft rotating brush rollers, cleaning the tiny grooves in the rough peel while limiting damage to the outer skin. The key point is that orange peel does not only carry dirt, but also contains a large amount of natural essential oil. If the peel is scrubbed too aggressively or torn, this oil can enter the juice in the later stages and create bitterness. So the entire washing step is not simply about cleaning the raw fruit, but about controlling the surface of the orange peel before it comes into contact with the extraction system. After washing, the oranges enter the sorting stage, where speed and precision happen almost at the same time. Thousands of oranges continuously roll across rotating rollers and optical sensors, where they are separated by size, color, and surface condition. Immediately afterward, high-speed cameras scan the entire line to detect bruised, cracked, or slightly damaged fruit that may be difficult for the human eye to spot. Although most of the process is now automated, many factories in Florida still keep manual inspection at the end of the line as a final screening layer before extraction. At this point, the most important stage of the entire process truly begins. The oranges are fed into industrial extractors that can process hundreds of fruit per minute, almost without cutting the oranges in half like conventional juicing. Instead, the system applies internal pressure to release the juice and pulp while limiting damage to the peel. This design is intended to control how much peel oil enters the juice, because if the oranges are pressed too aggressively, limonene from the peel can make the juice taste bitter and leave a sharp aftertaste. After impurities are filtered out, the flavor is adjusted and the juice is pasteurized and chilled. The orange juice is transferred to the bottling area. First, plastic bottles or paper cartons are sterilized to prevent microbial recontamination. The orange juice is then filled in an almost completely sealed environment to limit contact with air before leaving the factory. Interestingly, although the U.S. orange juice industry has changed dramatically, major brands still try to preserve the same Florida taste, the flavor profile that shaped Americans' orange juice habits for decades. Compared with many other growing regions, Florida oranges often have a clearer acidity, a stronger orange aroma, and a less sharply sweet aftertaste, making them especially suitable for chilled NFC orange juice. That is why, even though production has fallen sharply because of citrus greening, the phrase, "made from Florida oranges," is still seen as a flavor benchmark in the U.S. orange juice industry, and also as something Florida is trying to reclaim in its effort to revive the orange industry after years of decline. California, by nearly every measure, is a true powerhouse. Yet it is also a state carrying a fatal weakness within itself. Nearly 39 million residents live in a place without water. The paradox is that although nearly half of the state's total area is covered by desert and arid land, California is not only home to two massive coastal urban regions, but also the agricultural heart of the United States. Nearly all of America's leafy greens during winter come from Imperial Valley. Meanwhile, Central Valley produces nearly 40% of the nation's fruits and nuts, even though the region accounts for only around 1% of total U.S. farmland. By natural logic, this should have been one of the most difficult places in the country to develop agriculture. So, how did California achieve it? Part of the answer lies in advantages few places possess. California is almost a perfect natural blueprint, with a rare Mediterranean climate and more than 300 sunny days each year. In addition, more than 700 miles of the California Aqueduct, along with systems such as the Los Angeles Aqueduct, the Colorado River Aqueduct, vast irrigation networks, and groundwater extraction have pulled water from the north, from melting mountain snow, and from distant rivers to feed dry valleys. California did not wait for nature to allow it. It forced nature to serve it. But every system built to defeat nature comes at a cost. California's agricultural achievement is both a victory over natural limits and a growing contradiction. Agriculture now consumes about 80% of the water used by humans in the state, while the population continues to rise and the climate grows hotter. That is why the greatest debate in California is not whether agriculture has succeeded, but rather this question: how to divide a finite water supply among farming, cities, and the future of the state itself. Because despite every pressure, the fields here have never stopped operating. And to understand why that miracle still exists, we must begin with the very harvests that continue each day to resist the limits of this land. The journey of California's agricultural machine can begin with one of the most demanding yet most beloved fruits in the world: strawberries. Strawberries are extremely delicate and can be bruised after only a few minor impacts. So harvesting is almost a brutal race against time. As the sun rises, thousands of workers are already bent over the planting rows, hand-picking only the berries that have reached perfect ripeness. An experienced worker can harvest hundreds of pounds per day, earning around $18 per hour or more during peak season. With strawberries, the moment they are picked is the moment the race begins. While many states have only a short strawberry season lasting around 4 to 8 weeks, California can maintain harvests for 8 to 10 months, even nearly year-round in some coastal regions, thanks to its mild climate and overlapping production zones. This is an advantage no competitor can replicate. The state currently produces around 90% of total U.S. strawberry output, with more than 1 billion pounds per year, far ahead of every other state such as Florida or North Carolina. The commercial value alone often exceeds $2 billion annually, making strawberries one of the highest value fruits in the state. Those trays of strawberries are then moved immediately into cooling facilities, sorted, packed, and loaded onto refrigerated trucks within hours to reach distribution centers across the United States. From supermarkets, dessert chains, and restaurants to yogurt brands, ice cream, smoothies, jam, pastries, and countless processed food lines, all depend on the continuous daily flow of fresh California strawberries. From an ordinary fruit in the American market, avocado has exploded into a symbol of brunch culture, avocado toast, guacamole, and a billion-dollar healthy living trend. Originating from the ancient lands of Chile and Peru, avocados later surged strongly in Mexico before entering the modern North American market. Today, California is the largest avocado-producing center in the United States, dominating around 90% of domestic output, with roughly 300 million pounds per year, depending on the season. Unlike strawberries that can be replanted quickly, avocado is a perennial tree that requires 3 to 5 years before reaching commercial yields and demands a stable water supply through every season. On average, each avocado requires about 320 liters of water to fully develop, a figure that has sparked major controversy in California during prolonged drought periods. During the harvest season from around February to September, workers must use clippers to cut each fruit by hand, gently place it into bags worn on the chest, then transfer it into large bins to avoid bruising the skin. From there, avocados are sent to processing facilities to be washed, sorted by size, controlled for even ripening, and packed before being loaded onto refrigerated trucks headed to supermarkets across the United States. In a state facing both water shortages and mounting consumer waste, even avocado byproducts are being turned into new resources. California generates more than 40 million tons of waste each year, with single-use plastics posing a major challenge to recycling systems and coastal environments. As a result, avocado skins and pits after processing are being utilized at around 30% to produce bio-oil, cosmetics, compost, and many environmentally friendly biomaterials. Would you be willing to pay 1.5 to 3 times more for these green products instead of conventional plastics? No crop represents California's prosperity and the water cost behind it more than the most hated nut in America: almonds. California is currently the largest almond center in the world, supplying around 80% of global output and nearly 100% of U.S. production for many years. Each year, the state produces more than 2 to 3 billion pounds of almonds, with export value reaching billions of dollars. California's almond orchards are not sustained by rain. They are sustained by water carried from hundreds of miles away, flowing through drip irrigation lines with almost absolute precision. Every late winter and early spring, a massive biological migration takes place. More than 2 million honeybee hives from across the United States are transported by truck to California to pollinate millions of acres of almond orchards blooming at the same time, one of the largest pollination operations on the planet. During harvest season, usually lasting from around August to October, giant tree shaker machines clamp tightly onto the trunks and shake them violently for a few seconds so that all almonds fall onto the ground, which has been cleaned beforehand. After that, sweeper machines gather the nuts into long rows between the orchards, and pickup machines vacuum the entire layer of still-shelled almonds into storage compartments. From there, the almonds are sent to factories to remove the outer hull, dry them, sort them by size, inspect quality, and package them before being exported worldwide. But no crop has been criticized more than almonds. On average, producing just one almond may require around 3 to 4 liters of water. The problem is that almonds are a perennial crop. Once planted as orchards, farmers are forced to keep irrigating year after year to protect an investment that spans decades. With almonds, California cannot simply turn back. Its very success has locked in the choices of the future. If almonds represent wealth and controversy, then tomatoes represent California's pure industrial power. During the harvest season from around July to October, giant tomato harvester machines move straight into the fields, cut entire plants from the ground, then shake the fruit loose inside the mechanical system. Leaves, soil, and debris are removed while conveyor belts continuously dump tons of tomatoes into trucks driving alongside. In a short period of time, entire fields can be harvested cleanly, helping generate more than 10 to 12 million tons of processing tomatoes each year. But harvesting is only the first step. Because tomatoes ripen quickly and lose quality easily, trucks often drive directly from the fields to nearby factories. From ketchup in fast food chains, sauce on frozen pizzas, pasta sauce in supermarkets, to canned soup and convenience foods, millions of Americans consume California tomatoes every day without ever seeing where they began. California is currently the largest processing tomato center in the United States, often supplying around 90% of the nation's processed tomato volume. That is the paradox of California tomatoes. Less romantic than the image of traditional farms, yet one of the most efficient agricultural machines ever built. Generating more than $3 billion annually, eucalyptus is also considered one of the key factors that turned the 2019-2020 Black Summer into one of the most devastating wildfire seasons in history, causing an estimated $103 billion in damages. Eucalyptus is Australia's greatest paradox, a tree that supports millions of livelihoods while also acting like biological fuel, helping create some of the most intense firestorms on Earth due to the highly flammable oils contained in its leaves. Although nearly 80% of Australia's eucalyptus forests are natural, the country still has to plant millions of seedlings every year to sustain its massive forestry industry. Between May and July, nurseries become filled with young eucalyptus sprouts, and after around 10 years, the trees can grow taller than 30 meters, large enough to enter the industrial timber harvesting cycle. First, the harvesting machines move deep into industrial forests, equipped with hydraulic cutting heads that operate like miniature mobile factories. Unlike many tree species with curved trunks or complex branching canopies, Australia's eucalyptus trees grow almost perfectly straight, making them far easier to harvest. Within seconds, two steel gripping arms clamp tightly around the trunk with a force of roughly 50 kilonewtons, equivalent to the pressure of several tons of weight, keeping the tree stable while a chainsaw blade cuts cleanly through the base. Immediately afterward, steel-toothed feed rollers generate a powerful pulling force, dragging the trunk through a set of delimbing knives at speeds of up to 5 meters per second, stripping away branches and leaves almost entirely in a single continuous pass. Afterward, the long logs are lifted and stacked onto massive trucks by specialized loaders for transport out of the harvesting sites. In some rugged and hard-to-reach areas, heavy-lift helicopters are even used to airlift timber directly out of the forest. Eventually, the eucalyptus logs arrive at processing plants, where hundreds of tons of wood are sawed, milled, and pressed every day into a wide range of products, from pallets, furniture, paper, and engineered wood panels to even pencils. Thanks to its rapid growth, straight trunk structure, and ease of processing, eucalyptus has become one of the world's most widely used industrial raw materials, quietly surrounding people in everyday life without most even realizing it. Often described as an agricultural national treasure of Australia, mangoes have turned the country's scorching sun, dry soils, and harsh climate into a true goldmine, generating more than $600 million annually and becoming a premium delicacy sought after from Japan to the Middle East. To discover how this happens, we head to the Northern Territory, one of Australia's largest mango-growing regions in the north. Each April, as mangoes begin turning golden beneath the intense heat of the top end, the bustling harvest season officially begins. For shorter trees, workers harvest entirely by hand, gently twisting and lifting each mango to avoid bruising the soft flesh inside. When the fruit hangs out of reach, hydraulic lift platforms raise workers up to 5 to 6 meters high to access the dense canopies. Importantly, every mango must retain a short piece of stem to prevent sap from leaking out and damaging the skin or spreading onto nearby fruit. This sap can even cause skin irritation upon direct contact. As a result, almost immediately after being picked, each mango is quickly rinsed with a gentle stream of water before moving straight into a high-speed cleaning station. From the scorching mango orchards, the journey then continues into modern processing facilities, where the fruit is sorted, treated, and transformed into premium export products, freeze-dried mangoes, and many other high-value goods destined for global markets. Leaving behind the tropical mango orchards, we now head to Australia's avocado farms, where more than 115,000 tons of avocados are produced each year, turning this fruit into one of the rising stars of the country's agricultural industry. Unlike many mass-market avocados sold in the United States, which tend to soften quickly after long-distance transport, Australian avocados are highly valued for their thick flesh, high oil content, and rich, creamy texture. Here, avocado pickers do not focus on speed or quantity, but instead harvest with strict selection standards. Only fruits that have matured for 8 to 12 months, developed a glossy skin, maintained a firm structure, and show no signs of damage are kept. To reach the towering canopies, workers use long poles fitted with sharp cutting blades, combined with sturdy lifting platforms to access even the most difficult spots. Each avocado is carefully caught the moment it leaves the branch and gently placed into chest-mounted picking bags to prevent bruising the delicate flesh inside, before being neatly stacked beneath the rows of trees. At the processing plant, thousands of freshly delivered avocados are immediately fed into automated conveyor systems and moved into the cleaning section. After being washed with high-pressure spray nozzles and food-grade recirculating water tanks, they are further processed, peeled, and frozen to become frozen avocado products, or blended into the globally famous guacamole, winning over international markets with its rich, creamy texture and nutrient-packed flavor. Nicknamed the world's hardest nut to crack, macadamia creates one of the most fascinating contradictions in Australian agriculture. A shell almost as hard as stone on the outside, yet a rich, buttery kernel inside so valuable that the industry generates more than $300 million in export revenue each year. Few people realize that Australia is the only natural homeland of the macadamia tree, before the nut became a luxury product sought after from the United States and China to South Africa. Even today, the country remains one of the world's largest centers for premium macadamia production. Between March and June each year, as harvest season begins, macadamias are not picked directly from the trees like many other nuts. Instead, growers wait for the nuts to naturally fall to the ground once they reach perfect ripeness. Soon after, sweeping machines equipped with continuously rotating rubber brush rollers gently comb thousands of macadamias into the center rows, while causing almost no disturbance to the soil surface beneath. Next, collection machines move in, using roller systems and conveyor belts to gather entire strips of macadamias spread beneath the tree rows within just minutes. Immediately after leaving the orchard floor, tons of macadamias are loaded onto large trucks, passed through screening systems, and transported straight to processing facilities. Here, streams of macadamias are poured into enormous receiving pits before being carried throughout the factory by automated conveyor systems. After sorting, the nuts are transferred into controlled drying silos. This process can take anywhere from 7 to 10 days, because if the nuts are dried too quickly, the rich kernels inside can crack and burst apart like popcorn. But not everyone has the patience to conquer the rock-hard shell of a macadamia, and that is exactly why pre-shelled macadamias became so popular. To achieve this, Each nut passes through industrial shelling systems, where metal compression rollers apply just enough pressure to crack the shell open while keeping the delicate kernel inside almost perfectly intact. Finally, the macadamias undergo manual inspection, packaging, and distribution to markets all around the world. At the next stop on our journey, we head to Western Australia, the oat capital of the country, where the industry generates more than $500 million annually, approaching the scale of the U.S. oat market at around $542 million, and outperforming competitors such as China and India. Across these vast, endless fields, harvest season only truly begins when the oats shift from pale green to straw gold, and the grain moisture drops to the ideal level of around 15%. That is when gigantic combine harvesters roll into the fields. Their front cutting headers are lowered just enough to gather the thin, lightweight oat stalks before feeding them into the threshing chamber, where the grains are separated from husks, straw, and dust within seconds. After harvest, the oats are transported to modern processing facilities in Forestfield, Western Australia, where the grains that have just left the fields immediately enter a fully integrated production line. Here they pass through vibrating screens, air blowers, and metal separation systems to remove any remaining straw, dust, stones, and impurities left behind after harvesting. Next, the oats are dried and heat steamed to stabilize moisture levels, preserve their natural aroma, and prevent enzymes from causing rancidity. The tough outer husk is then removed, while the inner oat groats are rolled flat, chopped, or finely milled. From this point, the raw grain is rapidly transformed into granola, oatmeal cookies, and health-focused breakfast cereals, widely known for supporting heart health and helping reduce cholesterol. Home to some of the world's most intensely aromatic hop varieties, Australia has become a key supplier for famous breweries such as BrewDog and Sierra Nevada Brewing Company, generating more than $100 million in annual revenue. Many people assume the flavor and aroma of beer come mainly from barley, but in reality, the true soul of beer lies within the tiny hop cones packed with highly volatile essential oils. Between February and April each year in Australia, as harvest season begins, gigantic machines move into hop fields where the climbing vines can reach heights of up to 6 meters. Using powerful hook systems, the machines rip entire hop plants off their steel trellises within seconds. The flower-laden vines are then pulled onto conveyor belts like a massive, green waterfall before rushing into high-speed hop separation machines. Inside, rotating drums, brushes, and powerful air systems work continuously to strip thousands of delicate hop cones from the vines without rupturing the tiny oil glands inside, the very part responsible for the intense aroma prized by brewers around the world. After harvest, the 6 to 8 meter long hop vines are transported to processing facilities, where millions of fresh green hop cones are rapidly separated from the stems. Soon after, the hops are dried for 8 to 12 hours to lock in the precious essential oils and aromatic compounds contained within each cone. Finally, the hops are compressed into massive bales before being shipped to breweries, ready to blend with malt and yeast to create the beverage that has captivated the world for thousands of years. Avocado is a familiar fruit to people all around the world, but growing and caring for it is far more demanding than for most other fruit trees. For avocado trees, the timing of harvest is just as important as cultivation techniques. Growers must closely monitor the fruit's maturity, typically 9 to 12 months after flowering, when the stem begins to dry and the skin turns a deeper shade of green. Workers harvest avocados entirely by hand, relying more on touch and experience than on strength, A twist that's too firm can tear the skin. Too gentle, and the stem breaks in the wrong place, causing sap to leak and the flesh to darken quickly. For slightly taller trees, farmers use light aluminum poles fitted with small mesh bags at the tip to catch the fruit as it detaches, preventing it from hitting the ground. And for trees that reach over 6 meters high, hydraulic lifting platforms, extending up to 12 meters, allow workers to reach the upper branches without breaking them. The tree shaker is the secret weapon of modern plum orchards. Its steel arm grips the trunk firmly, then shakes it for a few seconds at a frequency of up to 400 revolutions per second. Just enough to make thousands of ripe plums rain down onto the catching tarp below, without damaging the branches or unripe fruit. In only a few seconds, a single tree can be completely harvested. From the large tarps, the plums are transferred directly onto conveyor belts, where they go through cleaning, sorting, and packing right in the field. Each tree shaker can harvest up to 60 tons of plums per day, working non-stop under the summer sun. With dozens of machines running together, the once tranquil orchard turns into a massive mechanized assembly line, where the rhythm of the harvest hums to the pulse of the machines instead of human hands. Alongside the trunk-clamping tree shakers, American farmers also use a specialized machine designed for low-trunk, narrow-canopy plum orchards, known as the canopy shaker. Its dual symmetrical rotor systems vibrate at a frequency of 6 to 10 Hz, transmitting gentle oscillations directly through the canopy to dislodge ripe fruit without breaking branches. Beneath the trees, a closed catching and conveyor system collects the falling plums, separates the leaves, and transfers the clean fruit straight into storage bins, turning each row of trees into a seamless, moving harvest line. Coconut is one of the most challenging fruit crops to harvest. The trees can grow 10 to 25 meters tall, with slender trunks, wide canopies, and fruit clusters weighing 20 to 30 kilograms each. Harvesters must battle height, wind, scorching sun, and constant danger. A single misstep can be fatal. In the past, most farmers climbed straight up the trees bare-handed or with ropes, using a curved sickle to cut each cluster. The job demanded not just strength, but also remarkable balance and skill. Few could scale dozens of trees a day and still come down safely. Today, in many major coconut growing regions like Western Thailand, farmers have learned to harness the power of water to reduce risks and save labor. Instead of climbing, they use poles or ropes to cut coconuts, letting them fall directly into canals. Thanks to their thick, fibrous husks, the coconuts float naturally. Workers simply paddle along the rows, gathering the drifting fruits into large clusters and towing them back to shore. This method is safer, faster, and far less labor-intensive. A single worker can collect hundreds of coconuts a day without climbing a single tree. It's a simple yet brilliant approach, turning the waterways, once a challenge of the delta landscape, into a massive natural transport system where coconuts float gently downstream to the collection point. And from now on, if I tell you that one person can move a ton of coconuts a day, you'd probably believe me, wouldn't you? Jackfruit may still be unfamiliar to consumers in Europe or the US, but across Asia, it's woven into everyday life. From street vendors' baskets to summer desserts at home. To Westerners, jackfruit sounds exotic. It smells strange, and its spiky shell looks intimidating. Some Americans even joke that it looks like a pineapple on steroids plotting world domination. Yet this odd-looking fruit is starting to capture the curiosity of American chefs. Jackfruit's fibrous texture makes it a surprisingly good meat substitute. Shredded, marinated with barbecue sauce, and served like pulled pork, all while being completely vegan. In Los Angeles, trendy plant-based restaurants now serve jackfruit burgers and jackfruit tacos, and they don't come cheap. Meanwhile, back in Asia, farmers still rely on instinct to harvest it. A dull thud when tapped, a faint stickiness on the stem, and a whiff of ripeness in the air. Jackfruit is a paradox of the tropics, humble yet grand, capable of sitting in a roadside basket one day and on a Michelin-starred menu the next. To you, tropical fruits are as temperamental as rambutan. It ripens fast, bursts into color, and if you're even a day late, a single rainfall can dull its red skin, curl its spines, and wash away its fragrance. For growers, rambutan isn't just a fruit tree. It's a biological clock, precise to the day. A mature tree can yield up to 5,000 fruits per season. About a week before harvest, farmers cover the canopy with a fine mesh, not for looks, but to keep fruit flies out, maintain humidity, and let the fruit color naturally without chemicals. When the spines soften and curl slightly, and the skin turns fiery red, that's the golden moment. Harvesters use poles fitted with small blades to cut entire clusters, delicately, like picking flowers, keeping the stems intact to prevent sap from leaking and spoiling the fruit's sheen. From March to June each year, when the blazing sun drenches the red basalt plains of Lampung, hundreds of workers begin the pineapple harvest. They move slowly through the low, razor-edged rows, twisting and snapping each fruit cleanly from its stem before tossing it into the keranjang, a woven bamboo basket strapped to their backs, weighing up to 50 kilograms when full. Pineapples aren't heavy because of their size, but because of their high water content, which makes up nearly 86% of the fruit's weight, turning every load under the tropical heat into a true test of endurance. That sweet pineapple scent wafting across the field isn't just fragrance. It's a trace of ethanol, and natural esters released as sugars in the fruit begin to ferment slightly under the sun. To seasoned growers, that scent alone tells the story of the harvest, because a good crop of pineapples always smells ripe on the wind before it's seen by the eye. The next part of the video takes us to vast dragon fruit farms stretching across Southeast Asia, a region that supplies more than 90% of the world's dragon fruit. From May to October each year, the harvest season reaches its peak. Across these tropical plantations, thousands of workers labor from dawn until dusk, as each fruit can only be picked within a short 2 to 3 day window after its scales turn bright red, the moment it reaches peak ripeness. Dragon fruit is harvested entirely by hand, using small curved knives to detach each fruit without tearing its thin, waxy skin. Because the fruit's flesh is soft and its peel easily bruised, every movement must be delicate, avoiding impact, pressure, or stacking that could spoil the fruit before it reaches the market. From the moment it's planted, soursop trees take about 3 to 4 years to bear their first fruits. When summer arrives, the orchard turns a lush green, a sure sign that harvest season has begun. Harvesting soursop requires absolute precision, as its flesh is soft and easily bruised. Workers use sharp shears or specialized knives to cut the stems, holding each fruit carefully in their palms before placing it gently into a padded basket. Every movement is deliberate, as if cradling one of summer's most fragile treasures. Before you stretches a sea of crimson lychee orchards, where millions of clusters are entering the busiest harvest of the year. The lychee season typically runs from May to July, when the hot, humid weather helps the fruit develop its deep red color, juicy texture, and delicate sweetness. Each worker can pick an average of 300 to 400 clusters per day, earning around $15 to $18 an hour at large farms in China and Thailand, two countries that together produce more than 60% of the world's lychees. After harvesting, the fruit is taken straight to wholesale markets or processing facilities within a few hours. There, lychees are washed, quickly chilled to 5 degrees Celsius, and sorted by size, color, and sweetness before being packed for sale.